It is the oldest question we have. It begins not in a laboratory, but on a dark beach or a field, staring into a clear night sky. It's the question a child asks, pointing at the Milky Way, a question that echoes the same wonder felt by ancient shepherds and early astronomers. Is anybody out there? This primal human query is the foundation of our myths and our science. For millennia, we had only wonder. But in the last few centuries, that wonder has been replaced by data. And the data has created a crisis. We learned that those pinpricks of light are other suns, and that our sun is just one of at least 100 billion stars in our own galaxy. The astronomer Carl Sagan famously reminded us that there are more stars in our universe than there are grains of sand on all the beaches of Earth. Our modern telescopes, like the Kepler and TESS satellites, have confirmed that planets are not the exception, but the rule. They have found thousands of worlds, many orbiting within the Goldilocks zone, the temperate region where liquid water could exist. Systems like TRAPPIST-1, just 40 light-years away, show us that multiple Earth-sized, rocky planets can huddle around a single star. The numbers are no longer theoretical, they are observational. There should be billions of Earth-like worlds in our galaxy alone. Given this cosmic immensity, and the 13.8 billion years the universe has had to work, our sky should be a blaze of activity. It should be a cosmic superhighway, swarming with probes, signals, and the visible engineering of ancient empires. Instead, when we listen, there is only silence. A profound, absolute, great silence. This is the story of the greatest detective case in human history, the search for the missing aliens. To grasp the true scale of this mystery, we must understand what we should be seeing. The math doesn't just suggest life, it suggests the galaxy should be overflowing. Let's start with time. Our planet is 4.5 billion years old, but our sun is a relative latecomer. There are G-type stars, stars just like our own, that are billions of years older. Imagine a civilization that emerged just 1 million years before us. In geological time, this is nothing. Yet, in civilizational time, it is an eternity. What could a society with a million-year head start accomplish? We must consider the Kardashev scale, a framework proposed by astrophysicist Nikolai Kardashev. A Type 1 civilization controls the power of its entire planet. A Type 2 controls its star, perhaps by encasing it in a structure like a Dyson sphere. A Type 3 civilization controls the energy of its entire galaxy. A civilization a million years ahead of us would likely be an advanced Type 2 or even a Type 3. We shouldn't be listening for their version of radio shows. We should be looking for the physical signatures of their existence. We should see the waste heat from their Dyson spheres, the mining of entire star systems, or the glow of their warp drives. Even at slow, sublight speeds, a civilization could colonize the entire Milky Way in a handful of million years using self-replicating von Neumann probes. By all logic, the galaxy should have been completely settled long before humanity evolved. Yet when we scan the skies for these megastructures, for infrared excess, for any sign of industrial activity, we find nothing. This is the paradox. The numbers predict a galaxy bustling with empires. The evidence shows an empty, pristine wilderness. This disturbing contradiction was famously crystallized not in an observatory, but during a casual lunch. The year was 1950. The place was the Los Alamos National Laboratory. The cultural backdrop was a new, nervous fascination with flying saucers, sparked by incidents like the Kenneth Arnold sighting and the Roswell controversy. The man who asked the question was Enrico Fermi, a brilliant Italian-American physicist, Nobel laureate, and one of the chief architects of the atomic age. He was walking to lunch with his colleagues, physicists like Edward Teller and Herbert York. They were idly discussing the UFO reports, laughing about the statistical probability of extraterrestrial visitation and the physical impossibility of faster-than-light travel. Then, as they sat down, Fermi suddenly, out of the blue, asked a question that cut through the chatter. "But where is everybody?" His colleagues knew exactly what he meant. This wasn't a joke. It was a deadly serious calculation. Fermi, a master of estimation, had performed a rapid mental exercise. He understood exponential expansion. He knew that any civilization with a modest head start and a basic grasp of rocketry could spread across the galaxy in a few million years, a short span of cosmic time. His question, coming from a man who had just helped humanity harness the power of the star, had a dark subtext. The silence of the universe, he implied, was not just a curiosity, it was a data point. It suggested that either building such civilizations was impossible or that they inevitably destroyed themselves. This became the Fermi Paradox, the profound, jarring conflict between the high mathematical probability of extraterrestrial life and the total, baffling lack of evidence for it. Enrico Fermi's lunch question hung in the air for a decade, a troubling piece of intuition. Then, in 1961, a young astronomer named Dr. Frank Drake tried to give it a formal structure. At a meeting at the Green Bank Observatory, the first ever conference on the search for extraterrestrial intelligence, or SETI, Drake proposed an equation. It was not designed to provide a precise answer, but to act as a tool for organizing our ignorance. The Drake equation, as it came to be known, breaks the enormous problem down into a series of smaller, more manageable questions. It asks, how many detectable civilizations are in our galaxy? To find out, you multiply a series of variables: the rate of star formation in our galaxy, the fraction of those stars with planets, the number of those planets that are habitable, the fraction of those where life actually arises, the fraction of that life which becomes intelligent, the fraction of that intelligence which develops detectable technology, and finally, the most critical and haunting variable, L, the length of time that civilization releases detectable signals before it vanishes. In Drake's day, almost every variable was a complete unknown. But thanks to missions like Kepler and TESS, we now know the first few numbers are encouragingly high. Billions of habitable worlds almost certainly exist. But as we move along the equation, we move from the certainty of astronomy into the deep speculation of biology and sociology. How common is the spark of life? How inevitable is intelligence? And most terrifyingly, how long do civilizations last? The equation's power is its revelation. The answer can range from billions of active civilizations to a cold, stark one. It shows us that our galaxy could be a bustling metropolis or a graveyard, all depending on a few great filters. Perhaps the paradox is built on a false assumption. We look at the billions of rocky, wet planets in the Goldilocks zone and assume they are all future Earths. But what if they aren't? This is the foundation of the rare Earth hypothesis, famously proposed by scientist Peter Ward and astronomer Donald Brownlee. They argue that while simple microbial life, the slime, might be common, the conditions needed to evolve complex, animal-level life are so staggeringly rare that Earth might be the only one. The Goldilocks zone is just the first step on a perilous cosmic checklist. For example, a planet needs to be in the galactic habitable zone, not too close to the galaxy's violent, radiation-bathed core, but not so far out in the suburbs that heavy elements for building life are scarce. It needs a stable, G-type star, not a volatile red dwarf that flares and strips planets of their atmospheres. It needs a massive, guardian planet, like our Jupiter, to absorb and deflect the barrage of system-clearing comets and asteroids. It needs a large moon, like our own, to stabilize its axial tilt and create the stable seasons necessary for advanced life to evolve. It needs plate tectonics, a planetary engine that drives the carbon cycle, regulates temperature, creates continents, and prevents a runaway greenhouse effect like the one that turned Venus into a hellscape. It needs a strong magnetic field to shield its surface from sterilizing solar winds. When you multiply the probabilities of all these factors, the number of Earths plummets. In this view, the silence is not a mystery. It is the norm. The universe is a vast, empty wilderness, and we are the anomaly. We are the jackpot winners of an impossible cosmic lottery. But let us challenge that. Let's assume the rare Earth hypothesis is wrong. Let's imagine the galaxy is teeming with Earths, billions of vibrant, living worlds. Our telescopes might one day reveal skies full of planets with oceans, continents, and atmospheres rich in oxygen. But this would only deepen the paradox. If life is everywhere, why is it so quiet? This leads to our next solution. The bottleneck isn't life, it's intelligence. The evidence for this is written in our own planet's history. Life emerged on Earth relatively quickly, perhaps 3.7 billion years ago. But then, for almost 3 billion years, an eternity, it did almost nothing. It remained a simple soup of single-celled organisms, like bacteria and archaea. Then, in the Cambrian explosion, about 540 million years ago, complexity finally arose. But even then, intelligence was not the goal. Of the billions of species that have ever lived on Earth, only one, Homo sapiens, has developed the capacity for abstract language, complex mathematics, and technology. The dinosaurs ruled this planet for 165 million years, a span of time that makes our entire human history look like a rounding error, yet they never built a radio telescope. Evolution does not select for smart. It selects for good enough. A shark is a perfect survival machine. A cockroach is a masterpiece of resilience. High intelligence is a bizarre, metabolically expensive, and perhaps even self-destructive evolutionary gamble. The silence we hear, then, might be the sound of a galaxy full of life, but a universe almost entirely devoid of conscious life. The great filter, in this case, is the near-impossible leap from biology to self-aware technology. This leads us to the most profound and unsettling solution to the Fermi Paradox. It's an idea known as the Great Filter. Proposed in 1996 by economist Robin Hanson, this concept reframes the Drake equation not as a smooth progression, but as a series of evolutionary hurdles, one of which is so difficult to clear that it acts as a filter, effectively destroying almost every civilization that attempts to pass it. The filter is a probabilistic barrier, a challenge so immense that it makes the transition from simple dead matter to a galaxy-spanning, Kardashev Type 3 civilization a near impossibility. This idea argues that the Great Silence is not an illusion. It is the result of this filter doing its job. The universe is quiet because almost no one ever makes it through. This concept immediately forces a terrifying question upon us. If such a filter exists, where in the long chain of evolution is it? Is it in our distant past, or does it lie in our immediate future? The answer to this question is the most important existential insight humanity could ever have. Finding evidence of any life out there, even simple bacteria on Mars, would be the most catastrophic news in human history. Because it would mean that the filter is not the creation of life itself. It would strongly imply that the filter is still ahead of us. Therefore, the Great Silence is not just a scientific puzzle, it's a mirror. It forces us to ask, are we the first to pass the test, or are we simply the next in line to fail? This is the optimistic and perhaps arrogant view. This is the hope that we are the miracle. In this scenario, the Great Filter is an event in our deep evolutionary past, a hurdle we have already cleared, while everyone else failed. The candidates for this filter are numerous. Perhaps it was abiogenesis, the initial spark of life from non-living chemistry. Perhaps this event is so statistically impossible, requiring such a perfect, chance alignment of molecules in a primordial soup, that it only happened once in this entire galaxy. Or perhaps, as we've discussed, the filter was the leap from simple prokaryotic cells to complex eukaryotic cells, a singular event that took nearly 2 billion years to occur on Earth. If this is true, the Great Silence is the sound of an empty stage waiting for its first actor. It means we are the first intelligent species to ever arise in the Milky Way. There is no one to talk to because we are the firstborn. This solution resolves the paradox in a way that is deeply flattering to humanity. It bestows upon us an almost divine significance. It means the cosmos is not a graveyard, but an unclaimed frontier. The responsibility for filling the galaxy with life, consciousness, and meaning rests entirely on our shoulders. We are not just one civilization among many, we are the galaxy's only hope. But this is a hope born of a profound, and perhaps unearned, sense of our own exceptionalism. This is the terrifying solution. This is the dark heart of the Fermi Paradox. This is the answer that suggests the Great Silence is a warning. In this scenario, The journey from abiogenesis to our current level of technological achievement is actually quite common. The galaxy, in this view, has been filled with countless civilizations that, just like us, looked up at their stars and wondered where everyone else was. They developed science, split the atom, built computers, and reached for the stars. And then, at a point almost identical to our own, they hit the filter. And they were annihilated. The Great Filter, in this case, is an inevitable trap laid by technology itself. What could it be? The list of candidates is a catalog of our own deepest anxieties. It could be nuclear annihilation, the moment a species discovers the power to destroy itself in a flash of nuclear fire, a button that always, eventually, gets pushed. It could be uncontrolled artificial intelligence, a superintelligence that we create for our convenience, which then, by logic or accident, optimizes the future for its own goals and eliminates us as an irrelevant byproduct. It could be an irreversible ecological collapse, runaway climate change, or a global pandemic engineered in a lab. Or it could be a technology we haven't even discovered yet, a physics experiment that triggers a vacuum decay event, erasing our bubble of reality at the speed of light. If this is true, the silence is the sound of a cosmic graveyard. The sky is empty because it is the final resting place of every species that became smart enough to invent its own extinction. But perhaps the Great Filter isn't a single, terrible event. Perhaps the filter is just the cold, hard reality of physics. The universe is not a neighborhood. It is an ocean of unimaginable, isolating emptiness. This solution argues that the Great Silence is simply a function of distance. We are trapped by the tyranny of the speed of light, the ultimate, unbreakable speed limit of the cosmos. Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. Our fastest human-made object, the Parker Solar Probe, traveling at its peak velocity, would still take over 6,000 years to make that journey. To cross our own galaxy, a stretch of 100,000 light-years, is a task that defies rational engineering. A relativistic ship traveling at 99.9% the speed of light would still take over 100,000 years of Earth time to make the crossing. The energy required to accelerate to such speeds would be astronomical, perhaps consuming the entire output of a star. Therefore, a galactic empire of the kind we see in science fiction might be a physical impossibility for any species, no matter how advanced. Civilizations may be confined to their home star systems as island universes, forever isolated from one another. A civilization on the other side of the Milky Way, just 50,000 light-years distant, could have risen, built a Type II civilization, broadcast its entire encyclopedia of knowledge, and died out 100,000 years ago, and its first, dying message still wouldn't have reached us. The silence, in this case, isn't a graveyard. It is the sound of a message, still in transit, across an impassable void. This leads to a related and equally profound barrier, the immensity of time. We tend to imagine the universe as a static stage, where all potential civilizations are actors performing at once. But the universe is 13.8 billion years old. Its history is a vast, desolate timeline. If we use Carl Sagan's cosmic calendar, and compress all of cosmic history into a single year, the Cambrian explosion doesn't happen until mid-December. The dinosaurs are wiped out by an asteroid on December 26th. All of recorded human history, from the first Sumerian cuneiform tablets to the smartphone in your pocket, fits into the last 10 seconds before midnight on December 31st. We have been a technological species capable of sending radio signals for only a few of those cosmic seconds. This is the problem of L from the Drake equation, the lifespan of a civilization. What if the average lifespan of a technological society is only, say, 10,000 years before it succumbs to a great filter of its own making? Our galaxy could have been home to 1,000,000 glorious empires, civilizations that mastered their planets and wrote epic poetry. But they are separated from us not by space, but by gaping million-year chasms of time. They are cosmic archaeology. The silence we hear is not an empty universe, but an ancient one. We are standing in a grand library, But all the books were written and turned to dust millennia before we were born. The galaxy is not empty, it is haunted. There is another possibility, one that is less about physics and more about our own profound lack of imagination. What if the universe is teeming with activity, but we are simply too primitive to perceive it? We are, by definition, searching for a mirror of ourselves. Our primary search method, SETI, scans the sky for narrowband radio signals. This is a technology we have been using for barely a century. It's the cosmic equivalent of a tribe in an uncontacted jungle listening for drum beats, while the sky above them is saturated with Wi-Fi, terabyte data streams, and satellite GPS. What if an advanced civilization masters radio and then, 500 years later, graduates to something instantaneous and undetectable to us, like modulated neutrino beams, gravitational waves, or communication via quantum entanglement? Or what if, as futurist John Smart suggests in the transcension hypothesis, all advanced civilizations inevitably turn inward? They don't expand into the cold, dead, and inefficient vacuum of space. They engineer inner space. They might upload their minds into vast, hyper-efficient virtual realities, matryoshka brains, living out millennia in simulated perfection, powered by the energy of their star. They would be post-biological, existing as pure information, completely invisible to our telescopes which are looking for water and biology. We are looking for something we can understand. But a true billion-year-old alien intelligence might be no more recognizable to us than the concept of calculus is to a bacterium. The great silence is not an absence of signals. It is our inability to recognize the symphony. This leads us to a group of solutions that are perhaps the most humbling. What if the silence is not a matter of physics or biology, but a matter of politics? What if the universe is full, but we have been deliberately isolated? This is the zoo hypothesis, first formally proposed by MIT's John A. Ball in 1973. He argued that advanced civilizations may be abundant, but they have placed us under a cosmic quarantine. We are not their peers, we are their subjects. In this scenario, Earth is a wildlife preserve, a sociological experiment to be observed from a distance, but never contacted. The motive for this might be benevolent, a prime directive, to protect us from the kind of cultural shock and societal collapse that would occur upon contact. They are zookeepers, waiting for us to mature and discover the laws of the universe on our own. Or, the motive might be purely scientific. They are watching us to see if we will pass our own great filter, the nuclear weapons, the runaway AI, the climate change. We are a case study in nascent intelligence. This hypothesis is deeply unnerving because it implies they are already here. They are all around us, using technology so advanced it appears as a law of nature, or is simply invisible to us. It suggests they have the power to reveal themselves at any moment, but choose not to. The great silence, in this case, is not an empty universe. It is the sound of a one-way mirror. We are not alone, we are simply and profoundly on display. But what if the hiding is not for our protection, but for theirs? This brings us to the dark forest hypothesis, a chilling solution derived from game theory and famously dramatized by author Liu Cixin. This hypothesis posits that the universe is a terrifyingly hostile place. It is a dark forest, and every civilization is a silent hunter, stalking through the trees. Every hunter is driven by two unchangeable axioms. First, survival is the primary need of any civilization. Second, civilizations continuously grow and expand, but the total matter in the universe is finite. The critical problem is the chain of suspicion and the vast distances of space. You cannot communicate with another hunter fast enough or reliably enough to verify their intentions. You cannot know if they are peaceful, or if they will remain peaceful in 1,000 years when their technology surpasses yours. Therefore, the only logical, winning survival strategy is twofold. First, stay absolutely silent. Do not make a sound, do not reveal your existence. Second, if you do detect another hunter, you must, without hesitation, destroy them before they can destroy you. It is a preemptive strike born of existential fear. In this universe, the great silence is not a mystery, It is the sound of everyone holding their breath. The sky is empty because all the noisy civilizations, the ones who naively broadcast their existence, are already dead. We are only alive because we have, until very recently, been too primitive to make any sound at all. Our first radio broadcasts may have been the equivalent of lighting a fire in a forest full of predators. Finally, we must confront the most direct solution, the one that violates the paradox's entire premise. The great silence is a lie. There is no silence because they are already here. For decades, this idea was the exclusive domain of fringe subculture, dismissed as UFO folklore. However, in recent years, the topic has been forced into the mainstream. Under the new, clinical designation of unidentified aerial phenomena, or UAPs, the conversation has changed. Leaked videos from United States Navy fighter jets, confirmed as authentic by the Pentagon, show objects performing maneuvers that defy our understanding of aerodynamics and propulsion. Official government reports now acknowledge the existence of these phenomena, admitting they are real, tracked on military sensors, and remain unexplained. We must approach this hypothesis with rigorous objectivity. If we assume, for the sake of argument, that some fraction of these UAPs represent a non-human intelligence, it does not solve the Fermi Paradox. It only deepens the mystery. If they are here, why are they so cryptic? Why the fleeting glimpses and the apparent disinterest in open contact? This behavior is inconsistent with an invasion, colonization, or diplomacy. It might, however, align with the zoo hypothesis, a discrete, scientific observation. But this solution only makes the silence of the rest of the galaxy even more baffling. Why are they the only ones here? Where are their rivals or their partners? Why is Earth the subject of this singular, clandestine attention? This hypothesis replaces one profound question with an even more immediate and unsettling one. The great silence is not an answer, it is an active question. And humanity is no longer content to simply stand on the beach and wonder. We are actively probing the void. The old search for extraterrestrial intelligence, or SETI, is being reborn. It's no longer just a few aging radio dishes hoping to overhear a hello. Today, we have projects like Breakthrough Listen, the most comprehensive and powerfully funded search in human history, scanning 1 million nearby stars and the 100 closest galaxies with unprecedented sensitivity. But perhaps the most profound shift is that we are no longer just listening for intelligence. We are looking for life, period. The James Webb Space Telescope is our first great tool for this. It is a chemistry lab and a time machine in one. It is capable of sniffing the atmospheres of rocky exoplanets as they pass in front of their stars. We are hunting for biosignatures, the chemical fingerprints of life. Is there oxygen, methane, or perhaps even technosignatures like industrial pollutants? We are moving from a passive search to an active investigation. The paradox, once a philosophical game, has finally become a testable hypothesis. But what if we use these new tools, scan 1,000 worlds, and the silence only deepens? What if the data begins to confirm our most arrogant hope or our deepest fear, that we are, in fact, alone? If the rare Earth hypothesis is correct, or if we are the sole survivors of a great filter that lies deep in our evolutionary past, what does that mean for us? It means the silence is not a mystery, but a canvas. It transforms humanity's role in the cosmos. If we are the only spark of consciousness in a galaxy of 100 billion stars, then our existence is no longer a cosmic accident, but perhaps the most precious and significant event in the universe. It means this fragile, anxious, self-aware life on this tiny blue planet is the only way the universe has of knowing itself. The silence, then, ceases to be a riddle and becomes a profound responsibility. It is a mandate. It commands us to survive, to protect this spark, to carry this flicker of thought and meaning out into the dark. If we are alone, our failures are not just our own, they are a cosmic tragedy. Our survival becomes synonymous with the survival of consciousness itself. We are brought back to that dark beach, staring at the stars, still holding the child's question. The Fermi Paradox remains unsolved. We have no definitive data to tell us whether the great silence is the sound of a graveyard or the sound of an empty stage. Is it a terrifying warning from the victims of a great filter that still awaits us? Or is it the quiet potential of a rare Earth, inviting us to be the first? We are left, suspended, in a state of profound and awesome uncertainty. But in the end, perhaps the paradox's greatest gift is not the answer, but the question. The search for them is, in truth, a search for us. To ask, where is everybody, forces us to first define what everybody means. What does it mean to be an intelligent, technological, and perhaps a surviving civilization? The paradox is a mirror. It forces us to confront our own future, our own technologies, and our own capacity for wisdom or self-destruction. The most important question is not, is anybody out there? The most important question is, who are we and what will we become? Which explanation for the great silence resonates most with you? Are we the firstborn of the galaxy or the survivors of a dark forest? Share your perspective in the comments below. We truly value your insight. If you appreciate this level of documentary storytelling and want to support our independent work, please consider subscribing to join the Stratum Logic community. To explore another mystery of our existence, click the video on your screen now. Thank you for deep thinking with us.